Alright guys, how's it going? So today we're going to go ahead and work with the Systems 2 test review. And we'll go ahead and work down the problems. I'll do my best to explain to you guys how to work these out. For the most part, the review does look very similar to the test, so let's go ahead and get started. For number one, we have what is the value of x in the solution for the system? And we have, as our system, we have our two equations. We have x plus 2y equals negative 10, and negative 3x minus 4y equals 9. Alright, so a problem like this, they're only asking me for one value. So if we're smart about it and we manipulate our equation carefully, we don't really do very much work. So for something like this, obviously if they're asking me for just my x value, the one that I don't need is going to be my y. Okay, so we're going to see if we can manipulate our equation to try to get rid of the y's. Okay, to get rid of anything with combination elimination, we want to create what we call a zero pair. Right, so a zero pair might be something like if I have 8y here, then I want negative 8y. Together, a positive and a negative term is going to cancel out. Right, so in this case, I'm trying to get these two things here to cancel out. Right, if I can manipulate my equation in some way so that those two things cancel out, all I'm going to have left is my x, and then my solution step should only be one step. Okay, in order to change something like this, I have to go in and I have to multiply the top equation by something so that it matches this bottom equation. Okay, so I'm going to go ahead and multiply the top one just because that's my smaller number. So we want to think about this a little bit. I want to create a zero pair with this negative 4. Well, negative 4y, the zero pair to that is going to be positive 4y. Okay, we're going to ignore the x, we're going to ignore the negative 10, we're just going to focus on this positive 2y. And then we just simply ask ourselves, okay, what would I have to multiply this by in order to get positive 4y? And our answer here would be 2. Okay. Once I put the 2 out there, I have to remember that I have to distribute not only to the 2y, but to all three terms. All right, so that's the x, 2y, and the negative 10. Okay, so we go in and we distribute. So first we do 2 times x, which is going to give me 2x. I'm going to go ahead and rewrite the whole equations down, both the equations down here. So we have 2x, 2 times 2y is going to give me 4y. Again, which is what I wanted. I wanted those two because that way they're going to create a zero pair and cancel out. And then we have 2 times negative 10, which is going to give me negative 20. Okay, I'm going to go ahead and rewrite this equation down here. Okay, so I distributed the first one. The first one became this, and then I just rewrote this one right there. Okay, so I've rewritten both my equations. Now that I have a zero pair, I usually tell my students, go ahead and box your zero pairs in. That way you know, hey, these two are going to cancel out. And you can also tell, yeah, one's positive, one's negative. That's just a really quick double check. So now we can go through, we can add our terms together. 2x minus 3x is going to give me negative 1x. And then negative 20 plus 9, again, all of these are plus, is going to give me negative 11. We're almost done. I don't want the negative 1 in front of the x, so I divide everything by negative 1. Negatives and 1s reduce. We're left with the x, and the negative 11 divided by negative 1 is going to be positive 11. And so that is my solution, right? Luckily for me, they only ask me for one value. They're not asking me for my y. So as soon as I tell them x is 11, I'm done. Obviously, if they ask me for y, I would go back in, plug it in, and then solve. You guys have done a few of these in class. All right, for number 2. And something like this does show up on your test. It says, what is the most efficient method for solving the system? And then it gives you your two equations for your system. Explain your answer in the box provided. Okay, so with something like this, your teacher will most likely accept almost any one of these answers, but the key word here is going to be for you to be able to justify your answer. Okay? So I'll go ahead and show you guys more or less how we would justify each of these answers. Alright, so for graphing, obviously before we type it into our calculator, if we're going to graph something like this, both equations have to be in y equals. Okay, so for something like this, you would say, I guess I'll go ahead and do A. If you're going to choose answer choice A, you would say, I'm going to solve for y. Y equals mx plus b, and type them into my calculator. So obviously, and if you want, you can even show a few steps, something like that you're solving for your y, you're minusing 3x. Right, so maybe going in and showing the step of, yeah, I can also solve it. Here's my first equation in y equals. I would do the same thing for the other one. Type them both in my calculator, and then go to graph. Some of your teachers might even want you to say exactly what you type into your calculator. For this one, if it's not a clear point and you're doing it with graphing, that means off of your calculator, it's going to be a graph. So it means that obviously these aren't the lines. I just graphed some random lines. But if you can't really tell where those two lines cross, then you're hitting second trace 5. And whatever equation you typed in, that would give you the point of intersection. So your teachers might want you to also say, well, I hit second, trace, and then the number 5. And then enter how many ever times. Right, so that's just kind of, so again, this would give you credit for you choosing A. So you have to go in and explain to us, well, I solved both equations, put them in y equals mx plus b. I would do it something like this. I then type this into my calculator, and that's how I can solve this with graphing. Okay, with next obvious one is going to be linear combination. Linear combination is the stuff that we're learning today. So you would say something like, make sure that one of them cancel. Make sure that one of the letters cancel, so create a zero pair somehow. Add them together, solve for x, plug the x back in, or plug the y back in, and then solve for the missing variable. So with something like this, again, you could just show that, hey, like the 5s match up. One's positive, the other one's positive. I can't have two positives, but if one of them was negative, then that would give me a zero pair, and then I could solve. So what you would say is, okay, well, I would multiply the bottom one by -1 so that they do cancel out. So maybe you show that step. Okay, so then you show the step where you distribute. That's going to be -4x minus 5y, and then minus 4. Right? If I multiply all of these by -1, all it does is change the sign. I'm going to go ahead and rewrite the top one just on the bottom just so we can see it a little better. That's the equation that I didn't rewrite. And so now I can show my first step of elimination, which is, hey, those two line up. That cancels out. I can then add these together. At no point does this say solve, so you don't have to solve it completely. As long as you can show us more or less that you understand what's going on, then it's going to be enough. And then obviously with substitution, you have to solve for one of these letters, so one of these has to be in y equals or x equals, and then show us the substitution step of you plugging it in. At no point should you really say calculator. I mean, technically you're using your calculator for this one. Technically you use your calculator a little bit for the combination to calculate some of the stuff out. Technically you use your calculator a little bit for the substitution, but calculator is not one of the methods that we learned. We learned how to do graphing, substitution, and linear combination. Those really should be one of your 3 options, and you should write something like this. The other method that we had was table. And obviously, if you're going to use your table, we want kind of like a screenshot of what you see in your calculator when you type these in. Alright, so something like that where you show us, hey, this is what I saw in my calculator, I saw the 2 5s here, so I knew that that was my solution. Alright, so just a little screenshot if table shows up as one of your answer choices. Alright, number 3. Burger shop sells hot dogs for $3 each and burgers for $5 each. One day the shop sold 25 more hot dogs than burgers and made $280. Write a system of equations that can be used to represent the situation. Alright, so again, anytime you have something like this, we have to write 2 equations. And it's sometimes difficult to tell exactly where our information is. I always say circle any important information, any numbers that you see, and then try to figure out your 2 variables. Alright, so in this case, again, a burger shop sells hot dogs for $3. So hot dogs cost $3. And burgers cost $5. Important information. One day, so usually this kind of signifies that this is going to be my first equation. Equation number 1. One day, the shop sold 25 more hot dogs than burgers, and they made $280. Write a system of equations that can be used to represent the situation. Okay, so obviously the 2 things that I don't know is exactly how many hot dogs they sold, and then exactly how many burgers they sold. So I'm going to go ahead and use those 2 variables. So off to the side, I'm going to go ahead and say that H, and we have B. Those are going to be the 2 variables that I use. H is going to represent not just hot dogs, right? We don't want to just make it too plain and obvious, not just hot dogs, but number of hot dogs. And the same thing with burgers, not just burgers, but the number of burgers. Remember that your variables represent things that you don't know, so that's the 2 things that we don't know. How many hot dogs and how many burgers. Alright, so let's go and start with the one day. So it says one day the shop sold 25 more hot dogs than burgers. Okay, so 25 is the key word, more hot dogs than burgers. So you want to think about this, excuse me. So you want to think about this kind of logically. Okay, so 25 more hot dogs, more is going to be plus, right? So to one of these we're going to be adding 25. And then you want to figure out which one they sold the most of, right? So we're going to read this equation again to figure out which one had more than the other. So they sold 25 more hot dogs than burgers. So my hot dogs is going to be the biggest one. My burgers is going to be the smallest one. Okay, so that means that in order to find out how many hot dogs I sold, and this equation is kind of backwards, but it's going to be that hot dogs, to figure out how many hot dogs I sold, I'm going to have to figure out how many burgers I sold, and then add 25. With problems like this, once you write your equation, go back and read the sentence again and make sure that it makes sense. So again, it says, one day the hot dog shop sold 25 more hot dogs than burgers. So that means that if I take the burgers that I sold that day, add 25, or in other words, I have 25 more than that, that's going to give me my hot dogs. Okay? Kind of a difficult equation to write, but that's what our first equation is. And then the other equation deals with money. So this one deals with, I guess, just the item sold. The other one deals with money. And obviously with the money, we're going to include all of our money values. We're going to include 3, we're going to include the $5, and then we're going to include that. This is going to be set up as a part plus part equals total. Right, so one part plus the other part is going to give me my total, and obviously in this case we're talking about total money earned. Total money that I made that day is 280, so I can set up this equation with 280 in terms of that's how much money I made. How I made my money was by selling hot dogs for $3 each, which I can write as 3H, burgers for $5 each, which I can write as 5B, and then that would be my second equation. And then once I sell so many hot dogs, so many burgers, I make $280. So this is my 2 equations for my system. Okay, it doesn't say to solve or anything like that. For something like this, to solve, you can either do substitution, or you can box this in, move the 5b over to the other side, pretend that h is y, solve for both, type them in the calculator. All right, number 4. Cade wants to solve the system of equations by using linear combination. What should he multiply the first equation by if he wants to eliminate the y terms? And then B, what should he multiply the first equation by if he wants to eliminate the x terms? So this is really, really big. Question number 4, go ahead and put a star by it. This is going to be something really, really big that you guys do have to know for your test, and that is, how do you manipulate your equation to cancel out certain terms, to create zero pairs for certain terms? Okay, so we'll go ahead and start with the y, start with A. So we're going to go ahead and isolate these two. Okay, to help me out, I have plus y. In between the plus and the y, I can put a 1. So I have 1y and 8y. What I'm going to try to do is I'm going to try to get these to become zero pairs. Again, remember what we talked about earlier. The zero pair would be something like positive 4y, negative 4y. Excuse me. So when we have one that's positive, one that's negative, they have the same term, same type of term. That creates a zero pair, and that gets them both to go away, right? That causes both of those things to eliminate. So I have to figure out, what do I multiply one of these by so that we have the same term for both? To do that, you always go to the smaller number. So 8 is my bigger number, so we're going to go to the smaller number. What do I multiply that by so that it cancels out? Okay? I only want to change one of my equations, so I'm going to leave this one down at the bottom. So far I have positive 8y. Obviously, to create a zero pair, I'm going to need negative 8y. Okay, so now the question becomes, what do I multiply the 1 by to get negative 8? Okay, well, I know that 1 times 8 is 8, so I can multiply that by 8. And then 1 times 8 is 8y, but I need negative 8y, so that should be a negative 8 instead. Again, I don't have to multiply this whole thing out, but I do want to show that if I do negative 8 times 1y, that's going to give me negative 1y. And then both of those would eliminate, and then I would just go through and solve for x. All right, part B. I'm going to go ahead and rewrite the equations down here so that we don't have to keep going back up. All right, part B says, what should we multiply the first equation by if he wants to eliminate the x terms? So pretty much same basic scenario. We look at the 2, we look at which one's smaller, this one's smaller, so I want to try to figure out something that's going to cancel out with the positive 16y. So obviously to cancel out, to eliminate positive 16, I'm going to need negative 16y. So that's my goal. What do I multiply this by to get negative 16? One other way to figure out something like this is obviously the number that I need in order to eliminate that, and then the number that I want, I can actually use some division to tell me what number should be out here. And that should be parentheses. All right, in order to do that, again, I would set it up this way to where you're kind of setting it up. You write down the number that you need down at the bottom. So if I have a positive 16 and a negative 16, those would cancel out, and that's what I want. So to figure out, how do I get this negative 16? You can kind of do that in your calculator. So you're going to do negative 16, the number that you want, divided by the number that you have. In this case, I have an 8. So I'm going to divide it by 8. Once I hit enter, I get that my number on the outside over here to eliminate my x's should be negative 2. Okay? I can even check it. Negative 2 times 8 is going to give me the negative 16 that I need, which is going to go down there. So negative 2 is what I multiply everything by to eliminate. Whoops, and that should be x's. Sorry, big mistake there. Sorry, to eliminate my x terms. So I go through and distribute negative 2. That's going to get rid of all my x terms. right, number 5. And there is a problem very, very similar to this on your test. Albert borrowed $60 from his brother, and he plans to repay him each week. At the same time, Albert started earning $10 per week in his college's cafeteria. When will the money he owes and the money he earns be the same? Graph the lines accurately. All right, so 2 different scenarios. We're going to graph one scenario at a time. Okay, so Albert borrows $60 from his brother, and then he plans to repay him $5 each week. Now, this kind of threw me off the first time I read it. Just because usually you think, okay, I'm borrowing money, I have negative amount of money because I have to pay it back until I get back to zero, right? But in this case, he borrows $60, so you think about it, you ask your parents, hey, can I borrow $60, or you ask your brother, hey, can I borrow $60? They give you that money. That means that money goes in your pocket, so you now, at week 0, have $60. Right, so that's how we would graph it. You have $60. Each week, you lose $5 of those dollars. So you have $60 in your pocket. Each week, you say, okay, here's $5. Okay, here's 5 more. Here's 5 more. Here's 5 more. Here's 5 more. Eventually, that $60 in your pocket will go all the way back down to 0. And then that's when you're done borrowing that money. So really, you're not really borrowing it to buy anything. You're just borrowing it to hold on to it. Okay? So each week he plans to pay $5 back. If we look at our y-axis, it's counting by tens. And obviously 5 is half of 10. So after 1 week, I'm going to pay back 5. So we can go ahead and even think about our equation. Our equation is going to be that I start with $60 and I pay back, which means that I repay, which means that I lose $5 each week. So my first equation should be something like that. Y equals 60 minus 5x. So each week I lose $5 more. So then after 1 week, I have 55. After 2 weeks, I now have paid 10, and I'm down to 50. Right, and so our line would continue down that same trend of 5 every week. So every week I'm paying back $5. Even after week 10, I'm still not done paying it back. Alright, so that's our first scenario. Our second scenario says, at the same time, Albert started earning $10 per week in his college's cafeteria. So now he's working. Every week he's earning $10. Obviously, whenever you start working, you start with 0. Right? So he starts working at his cafeteria. Obviously, if he doesn't do any work, he doesn't earn any money. So this one is going to be 0. But each week is $10, $10, $10, $10, $10. So after week 1, he's going to earn $10. After week 2, 10 more. After week 3, 10 more. After week 4, 10 more. Right, so forth and so on, all the way over to the end. Okay, so those are going to be his 2 lines. My equation for this other one, pretty simple. He has no y-intercept. It's just simply $10 per week. Okay, so I've shown you guys both ways to do it. You can do it through graphing. And obviously we're looking at when will the money he owes and the money he earns be the same. We're looking for the point where they intersect. If I connect my lines, you can see that they cross at that point there. So that would be the point, remember x value first, 4, 40. It does say graph the lines accurately for full credit. And then the point 440 means after 4 weeks. Both situations. Equal $40. All right, number 6. The entry fee into a basketball game is $4 for adults and $2 for students. Tuesday, the school collected a total of $428 from 178 people. write a system that can be used to find the number of adults and students tickets sold at the game on Tuesday. Okay, so Tuesday, they have so many tickets collected. Again, this is something that we've seen before on warm-ups. So first, for number 6, it says the entry fee to a basketball game is $4 for adults, and then $2 for students. Tuesday, the school collected a total, again, the key word here is total, of $428 from 178 people. All right, so again, we're going to write a system, which means 2 equations to find the number of adult tickets and student tickets sold at the game. So again, it tells you exactly what you don't know. It tells you need to find the number of adults and the number of student tickets sold. Okay, so with something like this, we can just set it up. Again, I always want to make sure that I label my variables. So I'm going to say A and S. You always want to make sure that they are different letters. If I had adults and apples, then I would have to make sure that I use a different letter for one of those two, right? Don't use the same letter for both. All right, so I have A and S, obviously adults and students, but what about them do I not know? I don't know the number of adults. I don't know the number of students tickets that I sold. So number of adult tickets and the number of student tickets. Number of both, that's the 2 things that I don't know. And then we have 2 totals, which these types of equations really aren't too bad to write. Again, it tells me we have a total of this much money and this many people. So that means that I'm going to write 2 equations. One of them is going to be for people. One of them is going to be for money. I usually write money last, but the order of it doesn't really matter. Okay, so first people. Obviously, what type of people are going to the game? We have a total of 178 people. I can go in and show you guys how our equation is going to look. It's going to be part plus part equals total. So that's what my 2 equations are going to be set up as. Obviously, the total amount of people that showed up was 178. And then the 2 types of people that showed up were adults and students. So the first equation is just simply A plus S equals 178. All right, with the money, all we do is just pretty much tack on the money that each type of person pays, whether you're an adult or a student, how much money you actually pay. And again, we have a different total. This time the total is that we have $128 collected. Whoops, 428. And then to figure out my total, how I got that total, I just basically tack on that each adult pays $4, which I can write as 4A, and then each student pays $2, which I can write as 2S. Right, and so these would be my 2 equations. All right, 7, 8, 9, and 10. Use any method. You must show all steps clearly and neatly to get credit on your test. Remember, all solutions should be written as an ordered pair, x, comma, y. Okay, so now they give us the option. You can solve these any way you want. This is kind of what we're talking about on Wednesday, which is something called best method. So most of these will have a pretty good way to solve, a pretty straightforward way to solve, and it's up to you to just kind of go in and find the best way to solve. Okay, so I'll solve 2 out of the 3 for you guys, just so you guys can see exactly what I mean. All right, so for number 7, we have 3x plus 4y equals 18, and then 2x minus 4y equals negative 8. Of course, I can use any method, and those methods being table on my calculator, graph on my calculator, substitution, and combination. Those are your 4 methods, the 4 ways that you're allowed to go in and solve one of these problems. Obviously, for table and graph, both of your equations have to be solved for y. They have to be when y equals mx plus b. So if you're good at solving for y equals mx plus b, then just go for it. Just go through and solve, get them in y equals mx plus b form, and then type them into your calculator, and then that works out. Right? Just, of course, make sure that you write your points, or your solution as a point. Substitution is a little different. You have to make sure that at least one of them is either x equals or y equals for you to be able to complete your substitution. And then combination, we add the equations together. Right, so we add our equations together if we're going to use combination. Okay, so with something like this, again, it's always important to see more or less what your equation looks like. In this one, something does stick out to me, which is that we have a positive 4y and a negative 4y. So in this case, my best method is going to be to do combination. When with combination, we are going to add our terms together. Positive 4y, negative 4y, those are going to eliminate. And now it's just 3 plus 2 is going to give me 5. The equal signs come down. And then 18 minus 8, or 18 plus negative 8 is going to give me 10. Okay, again, I have to show all of my work, and I have to make sure that my solution is the full point. So from here, I divide by 5, and I get that my x value is equal to 2. Again, because 10 divided by 5 is 2. Okay, so far my solution is that my x value is 2. Again, once we have x value, we then go to y value. I always tell my students, look at your x, look at your y. Try to pick the one that has positives so that you're not making mistakes with your negatives. So in this case, I would choose my top equation. I'm going to go ahead and rewrite it exactly as is. So we have 3x plus 4y equals 18. I now know for a fact in my solution that x has to be 2, so we take that value and we plug it in for x. I'm going to go ahead and rewrite that step. So now we have 3 times 2 plus 4y equals 18. Okay, now from here we can actually go through and solve. Remember that we can't solve if we have two variables, but once I replace the x with a number, and I make this into another number, I can now solve for my variable. I can solve for the y, which is obviously the one that I'm missing right here. Okay, first step is going to be to distribute, to get rid of your parentheses. So just 3 times 2, that's going to give me 6. Everything else comes down. And then we go in, box this in, and we solve. So we box in the 4y. That's what I'm solving for. I don't need the 6 on this side, so I'm going to get it to the other side. So we do minus 6 on both sides. 18 minus 6 is going to give me 12. And then 4y is going to come down. So now I have that 4y is equal to 12. And of course, I can divide everything by 4. 4s and 4s go away. We're left with our y. And then 12 divided by 4 is going to give me 3. All right, so then my solution is 2, 3. And then your teacher should have shown you how you can go in and check. It's a good idea to check just because on your test, these are worth quite a few points. So our solution was 2, 3. That means that x is 2, y is 3. So as I type these in, all right, so sorry, we can show our how to check our work. So I'm going to go ahead and type in the equation 3x plus 4y, but instead of x, I'm going to put in 2. Instead of y, I'm going to put in 3. So it's going to be 3 times 2 plus 4 times 3. And whenever I type enter, I should get the other side of the equal sign, which in this case is 18. Okay, so that first one works out. Second one, 2. Instead of x, I'm going to put in 2. And then minus 4, and then instead of y, I'm going to put in 3. And then whenever I hit enter, I should get the other side of this equal sign, which is negative 8. since both of these worked out, that is my solution. Okay. I won't work number 8 because if you notice, number 8 is actually set up the exact same way. Those two are going to cancel out. So really I go through, first step, add those two equations together. Okay. I'll leave this one for you guys to kind of practice your steps as you go through and you solve. For number 9, I'll show you guys a different way. I'll show you guys with the table and with the graph how you can also solve. Okay, so I'll go one equation at a time. I'm going to go and scratch this one out and rewrite it over here. Okay. Alright, so with something like this, remember that we can also solve both of these equations for y and then use either the table on our calculator or the graph. Okay, so if I'm solving for y, I usually tell my students box yours in. We're going to move the x. Both of these we should not combine. We should bring them both down. I'm going to go ahead and put my x first just because that way I'm going to have mx plus b. And then now we can go through and divide everything by 2. 2 and 2 go away. We're left with y, so we have y equals. In between the negative and the x, I can always put a 1. Excuse me. On your calculator, you can always do alpha y equals with the numbers. Remember that you can't do the letters, so we have negative 1 over 2 gives me negative 1/2. So negative 1x divided by 2 is going to give me negative 1/2 x. And then 10 divided by 2, half of 10 is 5. Okay, so that's my equation. Y equals negative 1/2 x plus 5. And then I can go in and solve my other equation. Again, I box in my y, that's what I want to stay. We can cover this up. I have to get rid of the 5x, so we do minus 5x. That goes away, this comes down. We have that y equals, same thing, I should not combine both of those. I should bring them both down separately. Again, I'm going to go ahead and write my x first, and then the 14 was positive, so I could put plus 14. Okay, so these are my two equations. I'll show you guys both ways that we can solve using our functions in our calculator. First one, well, obviously we have to type both of these in. Sorry, I'm struggling a bit. Alright, so I type in both of my equations in my calculator. I'm going to show you guys both ways to solve. So the first one is if we hit graph. This is solved through graphing. Obviously I can see that the two lines do cross. They cross at a point. Now that point is kind of hard to tell exactly what it is. So on your calculator you would do second, trace, and then go down to the number 5, which is intersect. It asks you the first curve, second curve, and then to guess. You don't really have to do that. You just have to hit enter. And then it tells you exactly where it's going to cross at negative 2, or sorry, at positive 2, positive 4. So my solution, just like that, I'm done. Solution 2, 4. Alright, so that's how we solve with graphing. We can also solve with our table. It's the exact same thing. Again, you have to make sure that your equations are typed in. Then you go second table. And then you're just looking for where y1, y2 match. So we're looking for these two columns to match, y1, y2, which they match at this point here. And so that means that my solution has to be one x value of 2, and then one y value, which is why we look for them to match. The one y value, since they're both 4s, is going to be 4. Right? Again, if you guys solve these for y, make sure that you say, well, I use second trace 5. Right, so kind of show, hey, these are the buttons I pushed. That way your teacher knows that's how you got that answer. Oh, sorry, you can't see that. Make sure that you show that second trace 5, those are the buttons that you push, that's how you got that answer. Or if you end up using your table, that you kind of do a little screenshot of this is what I saw in my table. You don't have to write a lot. Right, but just kind of a screenshot of, hey, this is what I see in my table. That one is my solution. Right, which is why I wrote 2, 4. Right, so just something like that. If you're going to go with the table or graph option, again, make sure that you show us, hey, that's what I typed in, that's what I got, and make sure that you have both of your equations solved for y. Or make sure that you have your table drawn and the point. All right, I'll try to get through the rest of these pretty quickly. Actually, this might have to be a second video.